Hello friends, in this video we will try implementing gradient descent. The required concepts is being done in the previous video. If you have not seen that, please watch that and come back to this video where we will be discussing about an iterative way of optimizing the weights. So in order to begin with, so I'll be using two libraries. One is NumPy, other one is Matplotlib. These are the two libraries. I'll be importing these two things and I'll be creating some synthetic data set for myself. I'll take some array of 5 digits, 5 numbers, and similarly I'll define x and y parameters. This is x. I have created an array with 5 elements. Correspondingly, y array I have created. One is the input array, other one is the output. So the next step would be initializing the weights. Let's initialize the weight. What are the weights that we have to initialize? So we are working on with W, B, right? So then we have to write some hyperparameters, right? So alpha value, I'll choose it as 0.01, which is my learning rate. And epochs, let me choose it for thousands. I hope you know what do we mean by epoch. If you require clarity, go back and watch the video on gradient descent where I've spoken about what do you mean by epoch, what do you mean by iteration, and what is batch size. So now I will start defining slope, intercept, and learning rate. I've defined initially the weights as 0, the slope is 0, the intercept is also 0, and alpha I have kept it as 0.01. Then, so I have to define one more value, which is m. What is m? M is nothing but the length of the samples. That is, in my case, it is 5. So in order to represent that, I'll write m is equal to length of x, capital X. After this, now I have to run my gradient descent loop. The next part would be gradient descent loop, where what am I trying to do is, I am trying to do the y prediction and update my gradients, compute my gradients. If you have seen, like after taking a derivative, whatever was those equations, that I'll write those equations and then compute update the parameters. We have seen what is updation formula for W and B, and then we will compute the losses. Okay, let me do that. So what all things that we are doing is, I'll go one by one. What is that I'm doing is, I'm trying to do the prediction part and I'm trying to compute these gradients. What is this? These formulas after taking a partial derivatives, which was shown in the previous presentation. And then I'll be updating the values of W, right? And then I'm computing MSE, mean square loss. Then I'll try printing, okay? Printing after every 100 steps. Let me run this. You can see now after every 100 steps, I am printing the value. Initially, when I started, the loss was 88.685. The value, the first time it got updated from 0 to 0.61, and the B after first time, when I started with 0, and after first iteration, it was 0.1798. Similarly, after 900 epochs, loss was 0.0098, with W has changed from 0 to 2.01 and B has changed from 0 to 2.9. This is what the values are. Now I'll try to final model and then I'll plot the results. To do that, what I'll do is I'll print the final values and then plot the values. So what am I trying to plot? I'm trying to plot the scatter plot of those values as well as the loss curve. Both I will print, right? You can see now the data points are shown with the red dots and the line which is fit is shown with the line, a blue color line. And you can see in this next plot, epochs versus MAC loss. As the epochs increased from 0 to 1000, you can see how loss has decreased. MAC loss has decreased. Say suppose you want to animate this part. You want to see like in the real time, you want to see like how the changes are happening. So in order to do that, you can run the same code, but in order to see animations, by nature, Google Colab does not support animation part. But if you want to see the animation part, what you can do is you can add the animation part. The same thing, I will add an animation function. The entire animation function I'll add and I'll show you that code. This is the animation in order to do that animation. But however, this will not run. If I show you, if I run also, it will show you directly this, right? So in order to make it animation, there is a piece of code which I have to run so that in the collab you can see the GIF file getting generated. Okay, this is a piece of code. I will put this code in the comment section. You can use this piece of code in order to show the animation part. You can see this animation. Okay, the loss curve also you can see. You can see in that epochs changing. Okay, how the values of B is getting updated and M is getting updated. Y is equal to mx plus c. Right. So this piece of code will be made available in the comment section. So you can use this to observe in real time like how changing of epochs will make the line random line to a best fit line. Hope you understood this. See you in the next video.